Assalamu alaikum. I'm Sarah Hamza Damanhouri, 5th B Farm. Our project research title is Preparation of chitosan-based nanocomposite hydrogel films loaded with cinnamaldehyde clove oil combination enriched with biosynthesized copper nanoparticles. So first of all, in this research, we prepared nanocomposite hydrogel films from chitosan by modifying chitosan films with cinnamaldehyde clove oil combination, and then it has been reinforced with copper nanoparticles. The nanocomposite hydrogels are polymeric networks with a special hydration property. In hydrogel synthesis, the addition of a cross-linker increases their stability under extreme temperature, pH, and pressure conditions. They have special characteristics such as high rate of swelling, selectivity, and design. Sensitive to stimuli. Biomedical uses include drug delivery agents, wound treatment, tissue engineering. The nanocomposite hydrogel films were prepared by solution casting methods. The results showed that the copper nanoparticles embedded chitosan nanocomposite hydrogel films showed a good antibacterial effect against E. coli and S. aureus and can be efficiently used in wound care. The chitosan. Chitosan is a linear polysaccharide composed of glucosamine and N-acetyl glucosamine units, consisting of the only cationic pseudo-natural polymer produced from the chitin deacylation. It has attractive physiochemical and biological properties such as bioadhesivity and film-forming ability on the skin and mucous membranes, strong flow properties, and antibacterial activity due to its particular chemical structure. Chitosan can be used in enhancing physiochemical stability, controlling the drug release, promoting mucoadhesivity and tissue penetration, modulating cell interactions, boosting antimicrobial effects, improving bioavailability and drug effectiveness. Cinnamaldehyde. Cinnamaldehyde is a well-recognized component of essential oil extracted from the cinnamon bark. Cinnamaldehyde has strong antibacterial properties as a natural preservative, antifungal effect, and has been licensed by the FDA. Cinnamaldehyde has a distinctive scent that can enhance food taste. The applications of cinnamaldehyde are flavoring agents in chewing gums, ice creams, candies, and drinks. It has been used as an antimicrobial as it is indicated for anti-caries treatment and has an anti-cancer activity. Clove oil. Clove essential oil is extracted from the clove tree's dry floral bud. It has an antimicrobial and antioxidant potential due to the presence of eugenol and other phenolic compounds. Its use in the industry is limited due to the extreme odor, volatility, and instability under atmospheric conditions, temperature, light, and oxygens. So, encapsulation of this oil seems to be a solution that encourages its use as an ingredient in the food. Moringa oleifera. Moringa oleifera belongs to the Moringaceae family. Almost all the parts of the tree possess medicinal properties, but the leaves contain a high nutritional source of vitamins, calcium, iron, potassium, proteins, and have an antioxidant and anti-cancer and hepatoprotective properties. The tree is known as a miracle tree or tree of life because of its multivarious use and medical properties as well as environmental value. Moringa has been profound potential as a source of bioactive constituents for drug production in the pharmaceutical industry. Copper nanoparticles. The uses of metal nanoparticles in their nanocomposite materials have currently been primarily recorded based on their structural and surface characteristics, Copper nanoparticles were selected to investigate antimicrobial applications among the current nanomaterials since the copper nanoparticles have been reported to be superior in antimicrobial activity compared to the other metal nanoparticles due to their physiochemical properties such as high melting point, temperature, magnetism, electrical and thermal conductivity, and light absorption and high heat transfer. The use of copper nanoparticles under environmental conditions and specific reaction conditions is limited by their own inherent instability, which makes it unable to be oxidative. The statement of thesis. The statement of the present research is focused on the preparation of chitosan-based nano-composite hydrogel films loaded with cinnamaldehyde clove oil combination enriched with biosynthesized copper nanoparticles for prospective applications in wound dressings. Copper nanoparticles were biosynthesized using leaf extract of Moringa oleifera with copper sulfate as a nanoparticle precursor. Cinnamaldehyde clove oil combination was reinforced with copper nanoparticles and loaded into the chitosan hydrogel films with view to enhance the mechanical strength and antimicrobial properties of the modified nanocomposite hydrogels. The nanocomposite hydrogel were developed in consideration with the following viewpoints. First, adopting green, environmentally friendly and cost-effective operations devoid of toxic chemicals with improved performance and less time and energy consuming protocol. And alternative utilization of natural products such as locally grown plants and essential oils for advanced pharmaceutical applications. I'm Melina Mgaldi, talking about aim of our research to study biosynthesis of copper nanoparticle in Moringa aloe vera leaf extract from a flower transformer infrared spectroscopy, ultraviolet and X-ray diffractions, and transmission electron microscopy to enrich, modify cinnamon aldehyde and clove oil by copper nanoparticles to investigate the possibility of loading cinnamon aldehyde and clove oil and cinnamon aldehyde and clove oil combination reinforced with the copper nanoparticle in cytosine hydrogel field. To study the structure, morphology, water absorption capacity, thermal behavior, hydrophobicity, biodegradation, and antimicrobial behavior of the prepared nanocomposite film. Material is cytosine, cinnamon aldehyde, clove oil, copper sulfate, Moringa oleifera leaves powder, acetic acid, deionized water to prepare hydrogel. Our method began with the preparation of Moringa oleifera leaves extract. Powder was boiled for 10 minutes in major quantity of deionized water in a Reminer flask. The quantity were cooled and filtered by Whitman filter paper. The biosynthesis of copper in Moringa oleifera, we take 1 milli of Moringa was added to 9 milli copper sulfate solution at 18 cellulose for 1 hour. The formulation of copper nanoparticle was converted by TM analyzed.
Assalamu alaikum. My name is Rizan Abdulaziz Al-Rifai, 5th year PharmD, and now I'm going to discuss the preparation of hydrogel films. By using only natural, cost-effective, and non-toxic raw materials, this reaction route was simple, devoid of toxic chemicals or solvents without the generation of toxic residues or side products. The reaction strategy complied with the principle of green chemistry, which is a tool in pharmaceutical chemistry. The steps of preparing of hydrogel films are the following. Chitosan filmogenic solution was added to 1A and to each of the flasks of the following, as you can see in the figure. 2A flask with cinnamaldehyde, 3A flask with clove oil, 4A flask with a combination of cinnamaldehyde and clove oil. And here, each flask was poured into petri dishes to dry at room temperature. And here, as you can see in the figure, in different flasks, chitosan was added to each of the following: 1B copper nanoparticles with moringa leaf extract, 2B copper nanoparticles with moringa leaf extract and cinnamaldehyde, 3B copper nanoparticles with moringa leaf extract and clove oil, and 4B copper nanoparticles with moringa leaf extract and a combination of cinnamaldehyde and clove oil. Then the solutions of B flasks were as well poured into petri dishes to dry at room temperature. They were white to green in color and produced transparent films on drying. Now here we have the characteristics of the nanocomposite hydrogel films. They were visually homogeneous. There was no sign of phase separation between components, also no brittle portions in any film nor any bubble entrapped within. All the films were foldable and transparent, and the films with clove oil were colorless and appeared more flexible, foldable, soft and delicate on touching compared to films with cinnamaldehyde. The films with cinnamaldehyde and clove oil combination appeared to have physical appearance intermediate of the pure clove oil and cinnamaldehyde films. And we would carry out later a thorough investigation in terms of structure, elucidation, morphology, hydrophobicity, thermal stability, and other analysis as planned at the beginning of the research. According to this transmission electron microscopy micrograph of copper nanoparticles in Moringa oleifera leaf extract, we have some points to be observed according to this micrograph. Our observations are the presence of spherical nanoparticles with well-defined boundaries, and that the nanoparticles are less than 50 nanometer in size. There was no agglomeration observed. Also, a gray sheet is visible, which may be correlated to the adherence of constituents of Moringa oleifera leaf extract to nanoparticles surface. Because copper nanoparticles subjected to the TEM analysis were not washed or purified, rather as prepared copper nanoparticles together with Moringa oleifera leaf extract were loaded in nanocomposite hydrogel. And here in the soil burial figure, nanocomposite hydrogel were buried under soil with a flag bearing a nanocomposite hydrogel film code planted above to mark the presence of that particular film beneath it. As the hydrogel films are buried under soil from time to time, they are dug out of soil carefully after different time intervals, like 24 hours, 48 hours, 1 week, 2 weeks, and so on. They were cleaned gently, and the changes in their appearance, texture, color, and weight were recorded. However, in our research, these nanocomposite hydrogels could be observed only for 1 week. Here in this figure, you can see the appearance of films after 1 week of soil degradation, and there were some characteristics of the films that we could observe. The first one is that the chitosan and the chitosan with clove oil discolored and was fragile and broke off in the end. The second one is that the chitosan with the combination of cinnamaldehyde and clove oil was intact and there was no discoloration. Also here you can observe the B category films appearance after 1 week of soil degradation. We have an expectation that with prolonged burial under soil, in which signs of biodegradation would appear and the films would be completely biodegradable. Let's get to the results of swelling studies of hydrogel films in water, and it showed that the films had good swellability in water, thus good tendency to absorb wound exudates if used in wound dressing is expected from these films. However, there is no data as such to present in thesis, and the investigation would be repeated later. In conclusion of this research, we succeed in preparing copper nanoparticles from Moringa oleifera leaf extract. Also, we prepared nanocomposite hydrogel films from chitosan by modifying chitosan films with cinnamaldehyde clove oil combination and then reinforced it with copper nanoparticles. Lastly, the cinnamaldehyde, clove oil, and copper nanoparticles are further expected to improve the mechanical strength and antimicrobial properties of nanocomposite hydrogels. In the end, I just want to mention the recommended studies to be carried out in the future. 1. Fourier transform infrared spectroscopy, ultraviolet and X-ray diffraction of copper nanoparticles. 2. The study of mechanical strength of hydrogel films. 3. Antibacterial and antifungal behavior of hydrogel films. 4. Degradation behavior of hydrogel films by soil burial test. 5. Assessment of applicational suitability of hydrogel films as wound dressing. And thank you.